If a gyroscope rests with one end of its axis on point A, it rotates around point A. This is called precession. To understand the mechanics of precession, we must first understand another bizarre behavior of gyroscope. If you try to tilt the gyroscope in the direction of the axis with a torque m, the axis will tilt in a different direction than expected. To explain this phenomenon, we transfer this example of the disc-shaped gyroscope analogously to a spherical gyroscope. This is because the torque m causes a rotation omega-2 around the z-axis. The two rotations omega-1 and omega-2 are then superimposed with a third rotation omega-3. If the gyroscope can only rotate around the x-axis, then the x-axis inevitably tilts in the direction of the z-axis. This direction of rotation can be determined using the right-hand rule. The index finger is used to represent the axis of rotation, x-axis, and the direction in which it points indicates the direction of the axis of rotation, corresponding to the direction of the angular velocity. The bent three fingers indicate an attempt to change the direction of the axis, and the thumb pointing upwards indicates the actual direction of the axis. This means that if an attempt is made to turn the gyro axis in the direction indicated by the bent fingers, it will tilt upwards in the direction indicated by the thumb. Now let's return to the precession. If the gyroscope is forced to tilt downwards by the gravitational force of the Earth, the x-axis is rotated in the direction pointing outwards from the paper, counterclockwise, using the right-hand rule. But how is the speed of the precession calculated? And we see that the speed of this precession becomes faster and faster as the axis approaches the horizontal. This is another strange behavior of the gyroscope. The precession is caused by the transformation of the torque direction, where the force arm remains unchanged. It is still the same force arm of the torque. The reference point A has not changed either. In the rules for inertial forces, we have explained that the maximum speed that an object accelerated by acceleration can reach is as follows. This r does not refer to the radius around the center of rotation. Rather, it is the length of the torque arm L in relation to point A. The speed of the precession can then be determined using the following rule for the speed of inertia. It is therefore fastest when theta is 0, i.e. when the axis of the gyroscope is in the horizontal position.